If it's echoing, let me know. I guess I need a earphone in order to not have echoing.
Everyone get ready for like the mute button in case like the headphones just like act up and kill everyone's ears if he tries this. Because you're trying something new, right?
Yeah, I'm trying to stream it, see what happened. Right now, I don't have the earphone.
Okay.
But I think it should have echo. Um, so I don't know if you hear any echoes on your side.
Oh, you started? No, nothing changed for us.
No, on the live stream. Can you check my channel and see?
YouTube?
Yeah.
Let's see. I'm not sure if yeah, I'm subscribed with notifications.
Cool.
Yeah.
Is it echoing?
No, I don't think it's echoing. Let me raise the volume on it. It's a bit quiet on YouTube.
Can you hear any sound?
No, it's pretty good.
It's pretty good. Okay. All right.
Yeah.
All right. So, what do you need to know in trigonometry for us going to a calculus? So, I want to review a little bit what kind of stuff you really need. If you're in my class, we didn't cover the full extent, so which is double angle identity. So, I want to talk about that today. But if you're from Mr. P's class, then you should cover everything. So, oh, cool. I can see chat.
It's really delayed on there, by the way.
Okay. But it's not echoing. That's all I need to know.
No.
Okay. So what kind of trigonometry you need to know? So let's talk about what's basic functions. So for example, sine of theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. And tangent theta is equal to 1 over cotangent theta. Now this is something that you have to know very, very, very well. It's called reciprocal identities. Okay, so there was also CSC of theta is equal to 1 over sine theta. SEC theta is secant theta is 1 over cosine theta. And the cotangent theta is equal to 1 over tangent theta. Now, this is a very, very useful thing to know throughout. So you cannot just say, want to go into Calc 2 and Calc 3. This is going to come back to haunt you each time. So I'd rather you know it now. Okay, that's called reciprocal identity. There's another one is quotient identity. Now, quotient identity is going to be tangent theta is equal to sine theta over cosine theta. And the cotangent theta is equal to cosine theta over sine theta. And those should be the one that you already know, and always very, very commonly used, right? It's very, very used very often. Another one is Pythagorean. Does anybody remember what Pythagorean identity is?
A squared plus B squared equals C squared.
Okay, thank you, Carrie. So this will be the geometry one, but it's not a calculus, not a pre-calculus one. So this is a squared plus b squared equal to c squared, but there was also another one for pre-calculus. Do you guys remember? Anybody else?
Sine squared plus cosine squared equals 1?
Yes, thank you. And actually, that's very impressive because you didn't even take pre-calculus. But wait, you did, right? You take it online. Sorry.
Online, yeah.
Yeah, you take it online, and that's good. Hopefully everybody knew that. Zach, do you know that?
No, I think I know it. Yeah, I know it.
Why you keep on like zooming to your face into the camera?
Oh, that's my background.
Oh, okay, that's very distracting.
Oh, sorry, I'll change it.
Well, it's better than cucumber one. Okay, so the thing is about it, where did I get it from? I'm gonna show you where I get it from. Imagine that there is a the triangle, right? And there was A, B, and C, and we know this is something called data. Okay, so therefore, we're gonna have A squared. This is the proof. I mean, you don't really need to know that, but I read student kind of see where they come from. Is you take the whole function, you divide it by C squared, and that's gonna be A over C squared plus B over C squared is equal to 1. Now, A over C, A is also known as opposite, and C is the hypotenuse, and B is the adjacent. So A over C is going to be opposite over adjacent square plus oh, it's not adjacent, it's a hypotenuse. I'm an idiot. Hypotenuse square plus adjacent over hypotenuse square is equal to 1. Does this make sense so far?
Yeah.
Yeah.
Opposite over hypotenuse is what?
Sine.
So it'd be sine theta square plus cosine square theta is equal to 1. Now, for you guys need to know is the square could be here or here. So they are same meaning. So it could be between the data or you had to put a parenthesis. But does not equal to the other one. So that's just something that notation-wise you need to understand. So either this one or this one, but not this one. Sine theta square, it's actually really bad because they are thinking about data squaring, not the whole function squaring. So this is not equivalent to sine theta square, but this one is equal to sine square theta. So those two are not equal to each other. So never this. I mean, not say never, but it's not a standard way to write it. Yeah, it's never to write it that way. Okay. So does that make sense? Now, what we're gonna do is we're gonna take this two function and we're gonna derive the other two functions. So what we're gonna do is this is the first one. You need to know for sure. But remember, this function can be written as sine squared theta is equal to 1 minus cosine squared theta, or it can be written cosine squared theta is equal to 1 minus sine squared theta. And this is a very useful tool because this one you can convert from sine square to in terms of cosine square, or cosine square can be converted in terms of the sine square. So it's very, very useful. But that does not mean Pythagorean has 3 identity. This is just only the first one. The first one can look 2 different ways. And those 2 different ways help you to do conversion. For example, you see something sine square and you want to change into in terms of cosines. And you had to do that when you solve an equations, and we did that in our class. Now, there was 2 other formats that you need to know. So what if I just take this function and so this side is only focused on the proof, plus cosine squared theta is either 1, and I decided to divide it by sine squared theta. And that's going to be 1 plus cotangent squared theta equal to 1 over sine. 1 over sine is known as cosecant, so it'll be cosecant squared theta. So this is the second one. 1 plus cotangent squared theta is equal to C SC square theta. Does that make sense? So that is the second one. Now, of course, this can write in three different ways, but this is the only one I really care. So this is the first one. Here's the second one. Any questions so far? Or you're confused so far?
I'm a little confused. Like when you converted it to the second Pythagorean identity formula.
I take it every function I divided by sine square of theta on every single term. Technically, you can divide everything by the same thing, and it's okay, right? So, for example, if you have, let's say 2x is equal to 4, you divide by both sides by 2, and that's perfectly normal.
Oh.
So in this case, you just divide by everything by sine square theta, and then you're gonna get cosine over sine. Remember this part? Says sine over sine is 1. Cosine over sine is from here. And 1 over sine is from here. And becomes the conversion of that and becomes clearly a different looking equations. Questions? Okay. Now for the third functions, so instead, I'm going to take the same thing, sine square theta plus cosine square theta. Instead of divided by sine square theta, I'm going to divide by cosine square theta. And that's going to be tangent square theta plus 1 equal to secant square theta. So there comes another one. It'll be tangent square theta plus 1 is equal to secant square theta. And this becomes very useful, especially on trig identities and trig integrations, and which is, I think this is a part that students gonna struggle. You may struggle like a 30% of the time on Calc 1, but you really will struggle like 80% of the time in Calc 2. So I'd rather you know it very, very clearly, this 3 equation, and where they derive from, because in case you forget on the test, you can always derive it yourself. Any question thus far?
Nah.
It's okay, right? Mr. P covered this, right?
Yeah, I remember all this from Mr. P.
Okay, good.
He did like at the end of the year.
Right.
Yeah.
So now I just want to make sure that my student knows this when they go into that. My student did cover till this part. Now I think Mr. P's class did cover to double angle and stuff like that. So I'm going to talk about double angle identities. Now for me is there was a proof for that. I won't memorize the proof. So I'll just give it to you. This is the one that you had to memorize. It's called double angle identity. So this is the thing that I didn't really cover in my class. I go through it really fast. Jackie, do you remember this?
Yeah, kind of.
Yeah, so this is called double angle identities. Now it's not, do you see that this 2 is not a power, it's not exponent, it's 2 sine of 2 angle is equal to 2 sine theta cosine theta. And this one is just like a, almost like a Pythagorean identity, but it's this one. It's like everything is reversed, right? Instead of start with sine square, start with cosine square. Instead of plus signs are going to be minus sign. Instead of cosine square, it's going to be exactly opposite. So this one, I just remember it's almost completely opposite of Pythagorean identity on the other side. So this is the 2 things I will always ask students to memorize. It will really helpful. And there is a derivation of this, which is also useful at times. So is this one? Um, I'm just gonna I'm gonna show you how to prove it. Okay, so there was two more. There was two more. So cosine theta. So instead of cosine square, this is a proof. I'm gonna show you the proof, and I'm gonna show you the end result too. So instead of cosine square, we talk about cosine square can change into something else. What it can change to is on the page.
One minus sine square.
Thank you. So I'm gonna use a different color. So let's show you the blue. 1 minus sine squared theta. Does that make sense? And that was the original one. So I just replaced this to this. And that eventually 1 minus 2 sine squared theta. And that's cosine 2 theta. So there comes the second one. I'm going to write down a proof again. Okay, so instead of cosine 2 theta, which is we're going to write it again. So we keep on writing it so that way we know it. So cosine squared theta minus sine squared theta. And we're going to replace the second one as opposed to the first one. So that's equal to cosine squared theta. And then replace that using, but you have to make sure when you do math, when you substitute something, you have to make sure there are parentheses because it kind of affect everything. And if that's the case, that minus sign is going to distribute both times. And that becomes 2 cosine squared theta minus 1. I should have used red. So this one is going to be 2 . Does that make sense? So that becomes the third one. So they are, I'm going to name this is a 1, this is 2, and this is 3. Now I will memorize this. How many of you guys are for sure that you know you're going to be an engineer in the future? No one?
I'm considering it.
Okay.
The idea.
So what happened is if you're engineer track, if you medical track, I don't know, most of the girls choose medical route, most of the guys choose engineer route. I don't know why is that, because I think girls can be just as good engineering as opposed to anything else. You know, I really think it this you had to break those social norms if you're female or you're male, right? So I think right now a lot of female students is breaking the traditional norm, which is good. They become doctors, engineers, astronauts, and I think I saw one is astronaut just in the NASA is a female astronaut, and she's really young too. So I really challenge a lot of female students here to be, break the norms, doing something other people won't do, be an entrepreneur, top 500 CEO in United States. Not many are women. Okay, not many are women. And that comes down to, actually that's interesting because the I think if you're in my class, I told you guys I actually invest money into the Bumble stock. It's not because I support the app, but I kind of support this. She's one of the female CEOs. And also I think a lot of people don't want to talk anymore. Like, you guys are kind of quiet. So maybe that's the only way to get a date. But I know most of people use that for different purpose, which is I don't think that's what the CEO's intention. If you ever listen to her talk, she's actually very interesting. Anyway, that was the 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 different ideas I was thinking about. Okay, so this three I will memorize it. Okay, and if Edwin says I'm thinking about a engineer track, which is some of you guys can also think that way, then you have to know two more equation. It's called power reducing. So power reducing is for Calc 2 only. And if you know for sure you're not going to be there, then I won't worry about it. But if you think about how do I do power reducing, it's actually super simple. Is to use double angle identity um, for especially 2 and 3. Hi, Thais.
Hi, Mr. Yu.
And solve for the squares. Right? What do you mean by solving for squares? So I'm going to take the cosine 2 theta is equal to 1 minus 2 sine squared theta. I'm moving the sine squared to the other side. So it'll be 2 sine squared theta, and I move the cosine 2 theta to this side, so it'll be 1 minus cosine of 2 theta. And then divided by 2, so that's going to be sine squared theta is equal to 1 minus cosine of 2 theta over 2. So this becomes a power reducing, but power reducing is actually getting from double angle identity 2 and double angle identity 3. So 2 cosine squared theta minus 1 is equal to cosine 2 theta. So I'm going to solve for the square, so I'm moving this to the other side. So it'll be 2 cosine squared theta is equal to cosine of 2 theta. Actually, I'm going to use the same track. Actually, just if I move to the other side, it's going to be 1 plus cosine 2 theta. And if I divide it by 2, that's equal to cosine squared theta equal to 1 plus cosine of 2 theta over 2. Now, this only for student go into Calc 2. So you don't have to worry about if you for sure you don't have to go to Calc 2. Then you say, I'm done. I just need to make sure I ace Calc 1. And you don't need to know those two equations because the chance that you're going to use it is not likely. Okay, not likely. And the chance that you're going to use in Calc 2 is about 30 or 40%. So you can probably do it without it, but there is a part is called a trigonometry substitutions, integral of trigonometry substitution that you really need to use this. So this is only for a certain chapter, not for every chapter, but that chapter you're going to fail that test, which is I don't want you to do that. I would rather review that. Does that make sense for everybody?
Mm-hmm.
Yeah.
Okay. Now, for most of the people, if you're in my class, I'm really driven up if you know the value. For example, sine of pi over 6, sine of pi over 3, tangent of pi over 3. And I think one point I did a staring contest with Jackie, which is she lost.
You can't start lying like that.
Which is but the thing I will say she's very impressive is she figured out, I don't know how did she do it, but she figured out how to control her eyeballs and not rolling at all when she answered a question. Now I give you a challenge right now for those of you guys not in my class, like trying to think about what is sine of pi over 6 without rolling your eyeballs. It's very difficult, right? So yeah, so you probably realize that your eyes is already moving. And Jackie was able to do it, and And I'm gonna be truthful. I didn't figure out how to do it until this year. Um, because prior year I've been teaching for pre-cal for like 10 years. I I just invent this competitions, and it didn't really. I wasn't able to do it for the last 3 years, and this is the only year I figured out a trick and to be able to do it. But yeah, so um, you have to know all the values. So for example, you have to know what is tangent of like 7 pi over 4, and you have to say that is a value. Like you have to know that. That's equal to, what is that equal to? Tangent of 7 pi over 4. Does anybody know? Oh boy. Nobody can tell me what's tangent of 7 pi over 4.
Is it -1?
Yeah.
Yeah.
Yeah, why is people waiting so long?
Because if we get it wrong, then we look dumb.
Exactly.
So no, I have an issue with that. What's wrong with getting it wrong? Do I ever make fun of you?
Yes, you do. Don't even lie.
No one's gonna back you up there, Mr. Ye.
Mr. Yet, even I'm gonna have to step in on this.
I have never make fun of a student if they got it wrong.
Like as a joke, but ouch.
No, Mr. I'm gonna be honest. I was just trying to swallow my food before I answered. So yeah.
She's trying to swallow food. Yeah, no, I never make fun of you guys ever.
You tell us we should know this because you spent a whole year teaching us this.
Yeah, but I never make fun of a student. I never like, oh yeah, you're stupid. How come you didn't know that?
No, it's more subtle.
Oh, more subtle.
And those are the painful ones. Like if you say directly, it's whatever. But like, ugh.
Okay, that's fair. I mean, it's possible. I think inside of my head, it's possible. But I don't do that. I really don't.
You just exposed yourself. You just said you thought about it.
Well, I thought about it this way. I'm gonna be honest with you. I thought about this. The way I thought about it is like I'm such a shitty teacher. Like no student knows how to do it. So that's
No.
that's the way I thought of it. It's not like how you so stupid you don't know how to do it. No, I really think it like I think of in term of um like how it represents as a teacher, so if I ask a question, like now if I go to other people's class, if I ask a question and they cannot answer it, I'll be, oh yeah, this teacher suck. I don't really think about students suck. I don't know if you know what I meant.
So it's the teacher's fault.
Yeah, like the teacher didn't teach it correctly.
Exactly.
Yeah, no, I sincerely think that way. I think every student can be taught. Now, now, like I have seen like some teacher was taught the other way, um, and they able to get it. I think Mr. P student usually have no problem too. Miss Nguyen student usually have no problem too. And I just didn't want to ask my student, and they didn't know. Okay, I like then I was like, oh man, I really suck compared to Mr. P or Mr. Nguyen, Mrs. Nguyen. Um, so that's a way I kind of judge of things, um, because I understand student at different level. Now, if you cannot answer, if you, or you answer wrong, I don't really go after you. I go after the teacher, which is in this case probably myself. Um, so
That brings back to the same thing, though. Do you think we want to make you feel bad?
huh?
that brings us back to the same thing. Do you think that we want to make you feel bad?
But you could. Why do you think that you're gonna make me feel bad? You might make me feel good. Like you might know the answer, right? You think of a glass as half full, or half empty. Yeah, half empty. Now I do think one thing though. I do think of one thing. Nonetheless, right? Regardless, right or wrong, you should never be afraid being wrong. It doesn't matter what other people say to you. You should never be afraid of being wrong. Long as you stand corrected, if you're wrong, then you should never be afraid of it. That's something I really firmly believe, but that's my thought process. Believe it or not. Does that make sense?
No, yeah, I agree too.
Yeah.
Yeah. So I really like. I really think like. But the problem is, I think what's preventing people from being successful is um, they're afraid of making mistakes. The fear of making mistake, that's what driving people fail. That sounds really interesting. It's something really, really different. But that's really, I firmly believe that is like the fear of making mistakes. I'm gonna give you an example. I have a relative, right? I have two relatives, and they all just came from Taiwan. And one relative learned how to speak English within very, very short amount of time, and one takes almost 3 years, including myself. Myself, it take me 3 years to really speak the first sentences, and the reason being is I really suck at language is because I'm afraid, like when I say something, other people gonna laugh at me. Okay, I'm really afraid of that. I'm really afraid, oh, people's gonna make fun of me because I can't speak English. I don't know if it applied to some of you guys. Some of you guys are immigrant, so you know what I'm talking about. Um, but a fear make you less likely to speak English. And the people who have no fear had no shame of saying things wrong, and they pick up a language really, really fast. And that's what happened is the little kids doesn't feel the things. They just like I don't care. They just say it, and they say it wrong, and people correct them, and eventually they speak English much faster than when you're older trying to learn English. Imagine you told your mom or grandmom to come here learn English, then it's gonna be really hard because they don't want to make a mistake. They've been living their life, nobody would laugh at them, but now all of a sudden they have to learn new language. Everybody's gonna laugh at them, and but that's only where the driven that where you fear and make you less likely to be successful. And I'm speaking for myself because I was one of those kids that fear of doing something wrong. And my advice to you guys, don't live 40 years of your life realize that's something wrong. Melissa, does that make sense?
Yes.
Right. So I don't know. Do you have to learn English when you come here?
I was born in Miami, but I didn't know English, so I was in ESOL for I think 2, 3 years maybe,
Okay.
maybe less.
Yeah.
I don't know.
The funny thing about Miami, I fly to from Miami to Cuba once, and I went to visit Cuba because it was a fencing competition. And in some situation, I went to Miami and I asked him where the bathroom is, and the guy's like told me like no English, no English. And I went to fly to Cuba, right? And I still need to go bathroom, so I went to fly to Cuba, and and the Cubans like, yeah, the bathroom's over there. I was expecting no English, but the Cuban airport people that work at airport actually speak better English than American Miami airport, which is pretty funny. But I don't know, does that happen to you guys? I don't know. But
No, yeah, Miami has it's like Little Havana, so there's a lot of sole
Yeah.
Spanish speakers.
yeah, and they can survive without speak Spanish, speak English, right? If you're in Miami, you can speak full Spanish without speaking a word of English.
Yeah.
You survive.
Mhm.
Okay. Anyway, sorry to distract you guys, but so this tangent 7 pi/4 you had to know is -1. Also, another way I can ask you it is probably like something with arc 10. So what is arc 10 of 1? And you have to say that's equal to pi/4. Because arc 10 is going to be a little bit different though. Arc 10 is going to be owning. So let me remind you guys, the arc 10 and arc-sin had the same restriction. And that restriction is right part of the circle. And arc cosine, I don't know, Miss P talk about this. Arc cosine is the top part of the circles, and arc tangent and arc sine is the right part of the unit circles. So when you answer a question, you really need to focus on the restrictions. So for example, if I were to say tangent of x is equal to 1, then you could have told me it says x is equal to pi/4 and x equal to um, um, 5 pi/4, right? But if I ask you arc 10 of 1, the answer can only be 1. It cannot be 5 pi/4. It has to be pi/4. I don't know if you guys remember this.
Yeah, I remember this.
Yeah, me too.
Okay,
Oh.
so make sure that arc 10 and arc-sin, they all have a domain restriction, right? Oh, actually, no. Sorry, it's not domain restriction. It's called range restriction because of the output. So range. So there's a range restriction for arc 10. There's a range of restrictions, and you have to really familiar with that. That's something that you're gonna use all the time. So let me give a question and see how you guys answer it. Okay, and remember, for you guys, I don't want you to be feared of getting wrong. You guys are the like one of the few hopes in Cyprus, and not saying that in a bad way, is because you guys actually care about learning, and that's why you guys will do this at summer and at 10:20, which is you could be playing Minecraft and Roblox, but you guys are actually here, or you probably do both. Sorry, for Carrie is probably doing both right now. So yeah, so you guys definitely something that I think um don't be afraid of doing it wrong. So let me ask you a question. So I'm not calling you guys. There's 15 students here. Um, so if a sine of x is equal to negative square root 3/2, what will be x equal to? Um, let's ask Esteban. Do you remember Esteban?
Wouldn't it be pi? I'm gonna guess like 4 pi over 3.
4 pi over 3? What else?
4 pi over 3 and
There's one more.
5 pi over 3.
Anybody can confirm this?
Yeah.
Yeah, I think.
Yeah.
Okay, good. Good job, Esteban. Everybody approve you. Okay, so remember, don't be afraid of making mistakes. Mistakes is fine. Now, Esteban did make mistakes. And if he did, and it's okay, it's perfectly fine. Okay, so now what if I ask arc sine, no, that's arc sine of negative square root 2 over 2. Anybody want to volunteer to answer this?
Negative pi over 4.
Negative pi over 4. Good job, Jackie. Let me ask another one. Arc tangent negative square root 3 over 3. Melissa?
One sec.
Melissa?
I'm blanking.
No pressure, no pressures. Answer now.
That just adds on to the pressure.
So what if you did it wrong? So try to do something wrong. I challenge you. Try to do something wrong.
Okay. Well. I'm gonna say negative pi over 6.
What does everybody think? Kathia, do you think it's right?
The last one?
Mm-hmm.
Yeah.
Okay. Julissa, do you think it's right?
Yeah, I think it's right.
Think it's right? Okay, good. Good job, guys. See? Is that so hard, Melissa?
A little bit. I blanked out because I was like, oh my god, I forgot. Because, like, you know how you told us to memorize the tangent things? And I was like, oh my god, I forgot about those. So I started freaking out. But
Okay, so for those of you guys don't know, I'm going to help you. Tangent at pi over 6 is going to be square root 3 over 3. Tangent at pi over 4, because sine and cosine is going to be the same number, the result is 1. At pi over 3, it's going to be square root 3. And that's going to reflect on all the quadrants. And that's the best way to know it. Kiri, do you remember this?
Honestly, no.
Is slowly coming back?
Well, the tangent part, no, but the arc sine and arc cosine, yeah.
Okay, that's fine. That's good. No, that's okay. If you don't know, then you gotta ask. So don't be afraid to ask questions. That's the next challenge. If you don't know, ask a question, because it might be you just more brave than the other people. And one thing I appreciate Kiri is she won't mind to ask questions. If she don't understand, she'll always be the one to ask. And I always appreciate her in my class because she won't mind to ask questions. Okay, so if you have a question, please do ask.
Mr. Yip,
Mm-hmm.
what topics did you go over when I wasn't here?
We live streamed it, so you just had to check the channel. We talk about the trigonometry you need to know in order to be successful in calculus.
All right.
Okay. Also, in this part, I want you to fill in is SOHCAHTOA. SOHCAHTOA is gonna help you in ACT or SAT. So that means sine of theta equal to opposite over adjacent, and you have to use that in calculus as well. It's in a place called related rate, so it's adjacent. Oops, I keep on writing it wrong. What's wrong with me? So did. Okay, so opposite hypotenuse. Can't spell hypotenuse. Cosine theta is this tangent data is equal to opposite over adjacent. Now remember, this one you're gonna use in the topic called related rate. It's a really difficult challenge topic, and we will talk about it, so you won't feel like you're lost over there. So related rate. Okay, and you're gonna use SOHCAHTOA and also SAT and ACT. So you have to know this. This is, I forgot to mention that. Okay. Any questions? Now the other day I said you guys cannot do it. I'm gonna take it back. I think you guys can do it. I think you guys should try it.
The worksheet from yesterday?
Yeah. So, what the hell is that smirk?
Like, okay, whatever you say. Like, okay.
Come on. Okay, so all this question is doable now. You should know how to do A because we went over that one. Normally I won't go over this, but I do think the trigonometry part you do need to understand. So I'll give you some freebies. You can ask me any questions, and I'll go over those. And the other question, I'm gonna ask you to do it. And even some of those questions, I might not remember how to do it actually. So any question you want to ask me here, or you can eeny, meeny, miny, mo. I'll go over that particular question. Any question? The first person get to ask, the better.
You wanna let us look at the questions first?
No, of course not. I always do that to my kids. Actually, my wife invented this, which is very smart. They'll be like, "Can we play electronic today?" And the way we always answer it is actually like, "Of course." And like 5 seconds later, it says not. And the kids is like, "No, why do you say not?" So next time somebody answers you, "Of course, not." So my wife's idea is we give you some hope, and then we crushed it at the end.
You found the perfect match for you.
That's evil.
Dad, can we go out tonight? Can I go out tonight? Of course. Not. I am evil. Yeah, I did find my perfect match. We're both evil.
Aw, and you said you weren't romantic.
I am not like I'm totally not. She probably storming in the room right now. She's like, yeah, he's not romantic. Any questions? Like you already see it for a few minutes. Or you can eeny miny mo, just ask me a question. I'll tell you if it's a good question.
Okay, how about 3B, Miss Tria?
3B. Ooh, you asked a funny one. 3B. Let's look at that one. You might stump me there. Remember which two-trick lemon you know, right? It was sine x over x when lemon x approaches 0. And the other one is Okay, I don't know, so I don't know how to do this question, so I'm just gonna try. Remember, I'm not afraid to make mistakes. So what I'm gonna do is I'm gonna make one of those two trigonometries happens, right? So the only one I know is sine x over x, or 1 minus cosine of x over x, something like that. So then I'm probably go with sine x over x. So what I'm gonna do is I'm gonna say I'm gonna take this functions. And it might be a little bit easier than that. I'm not sure. So let's just say I'm gonna try a couple different ways. Minus sine of x and over x cosine of x. And I'm gonna see, well, if that goes somewhere. I don't know if it does. So so far, do you guys understand what I did? I don't know if that's gonna make sense or not. So I'm just gonna go approach it. So I'm gonna say sine of x over cosine of x minus sine of x over cosine of x times cosine of x over x times cosine of x. So it's equal to limit x approaches 0, and it's going to be cosine of x. And this is the sine of x minus sine of x cosine of x. Don't write anything down yet because I don't know if I'm going anywhere. Times 1 over x cosine of x. And that doesn't seem like it's going anywhere. So I'm going to scratch that idea. So like I say, it's possible that you might not going anywhere. So you're going to say, okay, let's scratch that idea. So what I did is I tried to convert the tangent of x into sine of x over cosine of x and trying to simplify the fraction, and it didn't go anywhere. So what I'm going to do is I'm going to just use a different trick of the book. So what I'm going to do is one of the pretty powerful tool is this one. So x approaches 0. I'm going to take the 10x divided by x minus sine of x over x cosine of x over x. Do you see what I did?
Yeah.
I divide everything to that. And this x and x cancel out. And this one turned out to be the best idea because the other day we already talked about limit x approaches 0 for 10 of x over x is equal to, I'm just not going to write any limit anymore. So it'll be tangent of x times 1 over x. This one is what? Sine of x over x times 1 over x. And limit x approaches 0. And we talk about if that reached, this is a cosine of x. And we say this can switch places. So it'd be sine of x over x times 1 over cosine of x. Does that make sense so far? I'm just doing this part right now. And that eventually is equal to, this part is equal to 1 times 1 over cosine of 0, which is 1. So that part is equal to 1 minus sine x over x is also 1 over cosine of 0 is also 1. So it's 0 over 1 is equal to 0. So the answer is equal to 0. And let me double check, see if I'm right. 3b is equal to 0. Let me know if you have any questions. What I did.
Could you scroll up a little bit?
Sure.
Yeah, that's smart.
So what I did is I try to make sine x over x happen. That is my best friend. So if sine x over x happen, or even tangent of x over x is going to be the same answer as sine x over x. So in that way, it's actually pretty easy. I just show you how to do tangent of x because this one I showed you yesterday. So you should know how to do that. So that's going to be 1 minus 1 over 1, 0 over 1. Any questions? And I think this worksheet can help you review all the identities because a lot of identities help. So remember the two basic trig limits is limit x approaches 0, sine of x over x is equal to 1. And this one's going to become your best friend because if you know this one, they will help you out a lot. And there's another one when limit x approaches 0, 1 minus cosine of x over x is equal to 0. Because if I plug in 0 over 0 here, if I plug in 0, it's going to give me 0 over 0. So, how about I pick a question for you guys to try?
That sounds good, actually.
Okay. I'll pick G. Well, that's too hard. If you did it, just let me know you did it. And you can take a picture and send me through WhatsApp. And I will tell you if it's right or wrong. Carrie, you can send me a message. Carrie. Anybody got an answer?
I think I have an answer, but I'm not sure.
Send it to me. I'll tell you it's right.
Like private message? Like private WhatsApp?
Yeah. mean, if it's right, you can send it to the group.
I did the question and I got 1. I'm not sure how right that is. Probably isn't, but that's what I got.
Okay. But Valeria, you gotta send me the work. Because I don't see the work, I don't know. So is that Nor?
Huh? 11?
Who's that? Who's that voice earlier?
Oh, that was Salon.
Esteban, you can send it to me through WhatsApp, and I'll tell you this right or wrong.
All right.
And if it's right, I'll post on a group chat. Or if it's right, then you send it on a group chat.
Oh, it's gonna be sideways.
That's fine. I didn't get any though. Okay, so I'm looking at Esteban's work. Okay, so I see Esteban's. I'm gonna see. Valeria, did you send me?
It's not letting me send it. I'm trying to see if I like take the picture through my tablet if I can send it, but I don't know why my phone's not letting me. Give me a second.
Wait, just take a picture and send it to me, because you sent me a message before.
I sent mine, Mr.
Yeah, it's just every time I take the picture when it's showing up, like before I send it, it's showing up like only like the little corner of it. It's not showing up the whole picture. So I think it's just my phone. I'm not sure.
No, you just click plus and send, right?
Yeah, I know. I use WhatsApp for my family all the time. I think I don't know. Hold on.
All right. I think so we got answer of Valeria got 2, and the Carrie's got 2, and anybody else get 2?
I see what I did wrong.
Esteban, you see why it's 2?
I see what I did wrong. Yeah, I see why it's 2 now.
Okay. Anybody else get 2?
I didn't know how to do it, so I'm just kind of trying to find out what to do.
When did you get 2?
I'm still working on it, but I think I'm gonna get 2, yeah.
Kiri, it's okay. That's what I'm here for. So, do you remember those 2 trick limit I gave it to you, Kiri? Kiri, can you hear me?
Yeah, hello?
Yeah, did you remember those 2 trick limits I teach you? Did you write it down?
I did.
Okay, so that's okay. So that what I'm gonna do is we're gonna show you. You're not supposed to get it first time, so it's okay. Normally people are gonna be pretty much froze. Okay, but people's gonna get it eventually. So um, let me ask some other people. Says Edwin Norris, did you get it?
Nah. So
Jackie?
I'm kind of lost.
Jackie?
Nah, I'm super confused.
Super confused. Okay. Okay, so in this case, so it is normal that you're confused. So um Carrie, you wanna Carrie, you wanna send your work to the group chat?
Sure. Just give me 1 second.
I think Esteban, you did the right work.
Yeah, I did the right work. It's just I forgot. I just didn't do it in the beginning, and so it confused me a little bit, like
Okay.
where the numbers should be.
Right. Carrie, can you send it to the group chat? Hold on, man. I'll send it.
Oh, I just sent it.
Okay. I gotta send to Carrie. Carrie, I'm gonna send you WhatsApp link. So hold on a second.
Okay.
So that way you can go to the link. Share link to Carrie. Send. Okay, did you get it?
Yeah, I got it.
Did you guys understand what Carrie did?
I got the same answer and I don't understand what he did, so I don't know.
Okay. So what he did is limit x approach 0, sine of 2x over 2x squared plus x. What you can do is factor out x. So sine of 2x over x times 2x plus 1. Does that make sense?
That's not what he did though. What he did was multiply the top and bottom by 2.
Yeah, he just did that in 2 steps because
Yeah, that's why I was confused. I did it like that.
that's how he think about it. He multiplied 2 over 2.
Okay, if you look at the top, I did it like the first time, like where I can't cross it out. I did take out the x on the bottom, like in the first part, and then multiply it by 2 by
Yeah.
2.
You still have the right answer, so I mean.
So 1 over 2x plus 1. No, that's okay. I just read it in term that you can understand. And remember, if sine of x over x is equal to 1, so same thing as sine of 2x over 2x. So this part is going to give you 1. And this part, if you plug in 0, oh, there's a 2 here. My bad.
Mystery, I can't see the image.
Yeah, it's not showing that you're writing.
Oh, really?
For me?
Well, oh, sorry.
That's okay, don't worry.
Is showing right now or no?
The image shows, but it didn't show me that you were writing.
How about now?
I mean, I can see the image. Try writing again to see if it'll show up.
I only see the worksheet, not the image.
That's really weird. That doesn't make sense. Hold on a second. Oh, wait a second. Maybe I need to ensure this part. No, it's showing up right. So new share. So I'm gonna say stop sharing, and I'm gonna share, and the iPhone share. How about now? What do you guys see?
It's the worksheet.
It doesn't have any writing on it.
It does. It does.
Yeah, there's some blow.
Do you see what I did?
I see it.
That's what Carrie did, but he did it in very shorthand. And since I know Carrie for a long while, way too long, and I know how he functions. And Esteban had the right work. I think he just make a tiny mistakes too. So he make this happen. Okay, and then just plug in 0. So it's gonna be 2 over 1. And that's equal to 2. Carrie, do you see what's going on?
I see, but I don't know. I just don't really understand.
Okay, so do you see f factorial x on the bottom?
Yeah, I see that.
Okay, do you see I want to make either sine of x over x happen, or it could be sine of y over y. So long as they have the same variable. So the whole idea is moving this 2 in here and move rest to the other side. So this is the other side. So I move this and this into 1 fractions, and that part is going to become 1, and this part is going to be plug in 0, so it's going to be 2 over 1. So that's equal to 2. I had to plug in 0 for x, of course.
Okay, that makes a lot more sense. Okay.
Is anybody still struggle?
So I see that you separated the fractions, and the second fraction becomes 2 over 1. But the first fraction with sine 2x over 2x, what does that become?
That becomes 1, because limit of x approach 0 of sine x over x is going to become 1, or sine of 2x over 2x is going to become 1.
Oh, okay.
Mr. Yeah, I tried sending it to you because it's still showing up little. Is it showing up little for you, or can you see the whole picture?
I'm trying to look. Hold on. Oh. It didn't show up the whole picture, but it just showed up.
See, I don't know why. I don't know. I think I'm gonna delete what's up and reinstall it because I tried sending like a picture just random from my camera roll to somebody else and it did the same thing. So I don't know if it's just on my end or I don't know.
I don't know, but yeah, but it seems like you have the similar work from what I see.
I'm gonna try to do it again.
Okay. No, that's fine. No big deal. Just I mean, that's for your own good, because you're gonna have to send different things, homework or whatever, to other people. So does everybody understand what I did? Edwin, do you understand? Julissa, do you understand?
Yes, I understand.
Okay. Zach, do you understand? Melissa?
Yeah.
I mean, yeah, I get it. I mean, I get the way that Carrie did it more than that.
Okay, fine. No offense taking. It's okay. It's all good. Marvin, do you understand?
Yeah, I think so.
Okay.
Can you explain the sine 2x over 2x again?
Okay, so good. I like Thais is asking question, and I appreciate you. I think asking question is what make everybody understand. So the whole goal is to make this happen. This is your best friend, right? So you're gonna make this happen. Sine x over x is equal to 1. So so but you realize that x over x, they are the same variable. So if you have sine of 2x over 2x, limit x approach 0, you could have said 2x is equal to y. So it'd be limit y approaches 0 of sine of y over y. And that's just equal to 1. That's according to definition is this. This is trig definitions. Now, of course, later on you're going to use L'Hopital rule. It's going to be much more easier. But today I really want to train you to work with identity and understand trigs. Jackie, you got it?
Yeah.
Okay. Kiri, you got it?
Yeah.
No more questions?
Yeah. I was about to say, well, I already said it. But yeah.
My feelings not hurt. It's okay. Like I say, Melissa, you are Melissa, you're a better teacher than I am. Once you understand.
Okay, but to be a good teacher, I need to understand what I'm doing. And I don't know, Mystery. I think you get the crown for this specific subject.
Okay. All right. Well, next question. Do you anybody want to challenge for next question? Let's pick one. Anybody can pick one. I'll pick K. And the reason why I decided to go over this one is because I feel like students need to be able to see things a little bit different. So I was wrong, like saying you guys cannot do it last time. And I don't mind to say I was wrong because I think if I judge you guys, like have give you a low expectation, then you'll never met high. So I changed my ideas throughout yesterday to today. Is I really think about I will change the expectation, maybe hold you guys into high expectation still, because that way even you miss, then you still okay. And in calculus, you're gonna have to be able to see all the thing all different ways. So this is not gonna be the first exercise you're gonna see something new. It's pretty much every time you're gonna see something new, and you have to be able to adopt. And if you got an answer, send it to me. So this is the first time that you guys see different things. Like there is no structural way to do something, and I love it because you guys so used to structure. In calculus, there's no structure. You had to think about differently. What do you guys think? Don't overthink it though. I think a lot of people is gonna overthink this one.
Like, can I ask for a hint? As in, like I have a question.
I can give you a hint.
Okay.
You wanna take a hint?
Yes, please.
Okay. Have you ever seen? My favorite cartoon is Naruto.
Ooh. Okay.
Oh, Mr. Yeah. Oh.
I forgot my favorite character is. The guy controls shadows. But Naruto is definitely the idiot. But definitely Naruto is gonna help you on this problem.
Daddy.
Yes.
If you see a Blazing Beaks game on Nintendo, mommy let us have it. It's free. So.
I think a lot of people overthink this one. But think about Naruto, it does help you. Zach obviously doesn't like Naruto.
No. The first 3 seasons are good.
Wow.
Tolerable. The first 3 seasons.
I like the guy that controls the shadow. What's his name? Shikamaru, yeah. He's such a badass. I think that he's like the most fun to watch. Like
Yeah, but if it's cloudy out, then he does nothing. It's pathetic. He's weak.
That's true. Weak. Does he ever fight somebody in the ring?
In a filler episode, but then he couldn't do anything and got beat up. It was really funny.
For someone who doesn't like Naruto, you know a lot about it.
Well, yeah, I watched all like 970 episodes, but I didn't really love it.
Okay.
It's really 970 episodes?
No, wait. No, I think it's 770. Yeah, because the first one's 270, but then I don't know. How would I know?
I have to agree. The last few things just kind of like doesn't make sense.
I mean, it's a world of ninjas using fire powers, but yeah, that's the only thing that doesn't make sense.
So is every other anime. Like Dragon Ball. Do you like Dragon Ball Z?
No, I never watched it.
I start watching Demon Slayer.
Demon Slayer? Okay, some actual taste here. Okay, I see.
Yeah, how do you like it so far?
I only see the first season because that's only Netflix have it. So.
Well, I don't think season 2 is out yet.
Yeah, season out yet.
It's just the movie.
Yeah, have you watched the movie yet?
No, I haven't seen the movie.
That good.
No, the movie's really good.
Yeah, the movie is really good.
Really? Is it on the Netflix or on where?
It was in theaters.
Yeah, it was in theaters.
It was in theater. It might be on Netflix, but I don't know.
No, it's not on Netflix.
A Pirate's Life for me, Mr. A. We don't judge. You can watch it anywhere on Google.
Sure.
Just had to search it.
I mean, if you go to like Soap Today, it's like a bunch of pirated stuff.
Yeah, I could probably find you a link and just send it.
Yeah.
I haven't seen it yet, but I kind of the development of each character is kind of interesting on that one.
Yeah.
And I think there's a lot of potential if the episode's not out yet.
Yeah. And while you have time, you should watch One Piece though.
One Piece
I agree.
is
One Piece is really good.
Yeah, I just caught up and I started reading it. I started reading a book. It's been like 2 years since I've ever done that, but like, yeah, it's worth reading, and that's coming from me.
But I watched like first like 7 episodes.
They're not as good.
slow.
It's something. Yeah. Okay. This is gonna
It
sound
starts off a
weird,
bit slow, yeah.
but it gets good around like
The Nami arc.
Yeah, our long
It takes
arc.
like 50 episodes to get good. Trust
Yeah.
me,
No.
but it's good. It's worth it. It's worth it.
It's yeah.
Yeah, I'd say 35 is when it starts getting really good, but there's some bad arcs in the beginning.
Okay. So yeah, I watched it at the very beginning when like it just it was really slow development. It was like I had no patience for that.
Yeah.
It starts off slow.
Yeah.
But I think that's like just basically it.
Also, the
like,
anime's
really
worse.
But One Piece is pretty old, right? It's like
yeah, it's like 1990 or something.
Yeah,
I thought 30-year anniversary. I think they just did.
Yeah, that's my age, but I didn't see that. I grew up with Dragon Ball Z. I grew up with
Yeah, the first episode started in October 20, 1999.
Yeah, that's when I was
so they just did 20 years.
That's when I was in
Oh,
high
wait,
school.
no, the anime took a few years to come out. Never mind.
That's what I at high school. And high school I watched Naruto because they're about the same time. Oh, they're after. Hold on, I don't know. Okay, so do you guys got K? The answer is
Mr. I got it, but I think I did it a different way than how you do it.
I don't have to. Look. Okay. Valeria, math is there's no one way to do things. You don't have to do it my way. You don't have to do it anybody's way. As long as mathematically correct. Right? The answer is 9, though.
I'm gonna show you. I think I did it the way that you said that you're gonna teach it tomorrow, cause I think I've learned that before. Like when we just had a free day in my last year, well, like when I was in Dr. Phillips, but I'm gonna send it to you.
That's fine. Haven't get Oh, I got 2 people's work. Hold on a second. I got Carrie's work. Carrie says 3, but it's actually 9. But that's okay. That's good work. Did anybody get 9? Oh, a lot of people get 3. Oh, okay. So the idea is you cannot square root 8 things. So it's good that you guys showing this mistake that you guys think about you can square root something. I can't really square root something. If I square root a 4, it become 2. Right? You technically change the answer, so you cannot square root top and bottom. I think Esteban and Carrie both try that way, and it wasn't the best way.
Oh, okay, I see.
Oh, I'm looking at Valeria's work, and I don't know how did you convert sine squared of 3x into 3 sine of 6x? How did you do that again?
That's how they told me to do it before, but that was a long time ago, like last year, so it could have been wrong. That's the only way that I was able to get 9 from how I remember they told me before. But the teacher was not a calc teacher, so I don't know.
Okay. Anybody else have any good ideas? It's probably easier than you think. And here's how I approach it. Okay, it's gonna be sine of 3x times sine of 3x. And this, remember, my crew is shadow clone. It's pretty much like It's like Naruto at very beginning stage. He only can split to two, and that two really tells me that. Does that make sense?
Yeah.
And I multiply by 3 over 3 and multiply by 3 over 3. I'll move the 3 here. I move the 3 here. And this just multiplied together is going to give me 9.
I see.
And it's easier than it looks. I mean, those questions are for sure difficult for you guys because the first time you guys see math in this way, it's overwhelming. It's gonna be kind of difficult. Um, so I know it's almost 11:14. So if I were you, I would just take a screenshot of this, and you can take a screenshot of the second page, and you can try a couple and just see. Just and the thing is, I want you to do is look at a problem differently than before. So you can take a screenshot of this, and I also let you take a screenshot of the answer as well. And then this is gonna be your homework. And also you have to memorize all the things. It will help you next year. And so right now we cover the stuff. It's not even like very 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 relevant, but is the idea of seeing something new and you adopt right away. Right now, I like how Carrie is adopting very fast. Um, and Esteban is adopting very fast. Valeria's adopting very fast. It's you guys didn't really care. Just try freely, and even though you make mistake on the last questions, but you guys trying with the things that you know, right? And that's something to be very proud of, I think, because it's not about getting the right answer. I don't know if you hear the saying, it's never about a destination. It's always about, the time,
the journey.
The journey, yeah. It's always about the journey. And I remember, like, I don't know if you ever guys would travel to somewhere, and like more likely you don't remember that place that you travel to, for example, like New York, but you're gonna remember like the time that you travel, you drive all the way to New York, and what happened throughout the way. But when you go to New York, you only see Statue of Liberty and you're done, right? But the journey there is actually very interesting. The part of the things I want to challenge you guys is look at the adaptations of new materials and just adopt by jumping and says, let's do what I know. And let's not worry about what I don't know, because I think that a lot of you guys have that fear of the things you don't know and feel uncomfortable with. And that fear should be gone. If I'm the right teacher for you guys, then that fear should be gone. Hopefully that makes sense. But homework is homework. You don't have to do them. I can't give you credit. But I really strong you to challenge yourself to think about differently. And in the future, you're gonna be a future doctor, future interior designer, future things. So I think that's a or solve climate change or solve plastic problem in the world. Become a, I don't know, agricultural engineer like Melissa. She says she want to do. I'm pretty sure you're gonna face problems, right? And how do you adapt to that problem? Right? So we're not talking about just math. I can teach you math. Math is very boring, very dry. But the idea of not be fearful, being the idea of doesn't really give a shit about what people says, um, or doesn't care about what other people think about you. That's very important. That's important that you guys can do that. And even though it's mistakes. So I think I was more proud of Carrie and Esteban making mistake rather than they got the last question correct. Mistake is what gonna drive you to the next level. Not getting it correct. Correct is, it's a you will get there. I don't sometimes people take a long time. Some people take short time. But depend how fast you're willing to adapt. Does that make sense?
Mm-hmm.
Okay. All right. Yeah. If you want to try any question, and if you're ready to go, you can go. Yeah. And I need a recommendation for the earphone. So still haven't received one besides Hello Kitty.
Hey, it's a good recommendation.
I agree.
Okay, fine. Should I get one with the earphone and speaker at the same time, or should I just get a speaker earphone?
I mean, it's probably better to have like a headset with the little speaker piece on the side of it. You can always get like a cat ear attachment afterwards, so it's fine.
Or the Puka one.
No, you need the ears.
You could.
Or both.
A Puka Hello Kitty.
So the bonbons and the ears?
Exactly.
Mr. Can I leave now?
Yeah, go ahead, bye.
Oh yeah, I gotta work tomorrow.
Where do you work? Where do you work?
The competitive season is starting tomorrow, so
have a
you
good
gotta
night.
get ready.
Bye. Have a good
No,
night.
I actually have work tomorrow. Good night.
Bye.
Bye.
Thank you.
Bye.
Oh, I was muted that whole time. Dang. Oh well. It's just the three of us now. Oh, Mr. Ye, do you want to test the thing now or no?
Yeah, but I don't have a speaker. I mean, I don't have an earphone.
Oh, okay.
Okay. You need to tell me what type of features you want.